Okay, let's have an example for the shooting method. Okay, for example, a second order ODE BVP. And the second order ODE is y double prime plus 3xy prime plus 7y equals cosine 2x. Okay, this is our second order ODE. With the BVP, so boundary value problem, y0 equals 1, y pi equals to 0. So you can see that both of them are now passing through the same points. They are the boundary value problem. Then the first step, what we introduced before, is you are trying to convert the second order ODE into two first order ODE and writing as a state space representation. Okay, so convert second order ODE into two first order ODE and write as a state space representation. So let z equals to y, z1 equals to y, then z2 equals to y prime, z2 prime will be equals to y double prime, and y double prime will be equals to negative 3xy prime minus 7y plus cosine 2x. Okay, so that is the two first ODE. Okay, then we will write as a state space representation. And we have d over dt, so as function of t, okay, or it should be as function of x. Let's see. D over dt, z1, z2 equals to, sorry, should be as function of x. D over dx, z1, z2 will be equals to some coefficient times itself, z1, z2, plus some coefficient times the Folsom function. Okay, Folsom function is cosine 2x. Then let's figure out what is the coefficient based on our writings. Okay, so z1 prime will be equals to z2, right? So z1 prime will be equals to z2. Will be 0, 1. z1 prime equals to z2. And the Folsom function will be 0 here. Then z2 prime equals to what? Equals to minus 3xy prime minus 7y plus cosine 2x. Then we can write it as a function of z. Okay, so y prime will be z2, will be 3x z2 minus y will be z1, 7z1 plus cosine 2x. So the coefficient for z1 will be minus 7. The coefficient for z2 will be negative 3x. Then the Folsom function is 1 here. So that is our state space matrices. Try to figure out by yourself so that later you will know how to do this. Okay. Then another thing we need to figure out is what kind of, missing conditions we need to have, right? So as our boundary values, we have y0 and y pi. We don't have the y prime at 0 point. So we are missing the y0 prime. Then the second step is set up as an initial value problem by giving a guess value, which is y0 prime. Okay, y0 prime equals to alpha. Then you z0 will be equals to y10 and y20. okay? Y1, 0 will be, so Y1, 0 and Y1 prime 0. And Y1, 0 we already know that is 1. Y prime will be alpha, that is our missing conditions. We are giving the guess, okay? So we have this initial values. Then we are trying to do another guess, okay? Give the beta. Okay, another guess set up as an initial value boundary conditions by giving another guess. Another guess will be what? Will be beta, right? So you will set up another guess, which is the beta, will be Y0 prime will be equals to beta. Then you have the boundary conditions is 0, Y1, 0, Y1 prime 0 equals to 1 beta, okay? So you give this 2 initial guess and you are trying to do the arrow analysis to figure out what can be our next guess, okay? So let's do the arrow analysis. So the first step will be the arrow analysis. The arrow analysis is doing what? So you have arrow 1, which is z at, so the next point will be pi, based on your initial guess alpha, minus y pi. And y pi you already know that is equals to 0, right? The arrow analysis 2 is the pi at beta, right? Minus y pi. So you have these 2 arrows already. And you are trying to figure out what is the better guess, right? So you have the delta k will be equals to negative arrow 2 divided by delta arrow over delta k. And this delta arrow divided by delta k is arrow 2 divided by delta arrow will be arrow 2 minus arrow 1 divided by beta minus alpha. So that you figure out what is UK. And then you're doing the next guess, right? The next guess will be based on this delta K. So the next guess will be Y0 prime will be equals to beta plus delta K. And you will do this next guess and solve the IVP and see if that meets your tolerance or not. Until it meets the tolerance, then you finish your BVP problem, okay? So the fifth will be repeat until, so repeat since step, repeat since step 3, you have the guess until the arrow will be smaller than your tolerance. And the tolerance is you set up, okay? You set up, then it will be done, okay? So what we have here, we can do arrow 1 with the initial guess alpha equals to 1 minus 0.034794. And you have arrow 2, which is beta equals to negative 1. You have negative 0.024041, okay? And you have the delta K will be equals to the arrow 2 negative divided by delta K is around negative 4.4715. So the alpha nu will be equals to the beta plus delta K will be equals to negative 5.4715. And you can input this value into your IVP problem. You can see it's already met for the tolerance, okay? So that is how efficient such arrow analysis is meeting for the shooting method.